Engineering in Ancient Egypt. Ancient Egypt, known for its monumental architecture and advanced engineering, remains a testament to human ingenuity and the capability to achieve remarkable feats with limited technology. Spanning over 3 millennia, the ancient Egyptian civilization harnessed engineering skills that continue to astonish modern scholars. This text delves into the multifaceted aspects of engineering in ancient Egypt, exploring its principles, techniques, and the monumental structures that symbolize their achievements. Historical context. The civilization of ancient Egypt flourished along the banks of the Nile River from around 3100 BCE to 30 BCE. Engineering in this context was driven by practical needs such as irrigation, construction, and transportation. The fertile lands of the Nile Delta allowed the Egyptians to develop a sophisticated agricultural system, which in turn supported their advancements in engineering. Early beginnings. In the early periods, Egyptian engineering focused primarily on irrigation. The Nile's annual flooding deposited nutrient-rich silt on the surrounding lands, making them highly fertile. However, controlling and channeling these waters to maximize agricultural output required sophisticated irrigation systems. Early Egyptians built basins, canals, and dikes to manage water distribution effectively. Architectural marvels. The most enduring legacy of Egyptian engineering lies in their monumental architecture. The pyramids, temples, and tombs are marvels of engineering that demonstrate their advanced understanding of construction techniques, materials, and geometry. The Pyramids of Giza. The Pyramids of Giza, particularly the Great Pyramid of Khufu, stand as a pinnacle of ancient Egyptian engineering. Constructed around 2580 to 2560 BCE, the Great Pyramid was the tallest man-made structure in the world for over 3,800 years. 1. Design and planning. The construction of the pyramids required meticulous planning. The alignment of the pyramids with celestial bodies indicates the Egyptians' understanding of astronomy. The Great Pyramid, for instance, is aligned with the cardinal points of the compass with remarkable precision. 2. Materials and labor. The primary building material was limestone, quarried locally and transported to the construction site. Granite, used for the inner chambers and the pyramid's casing, was transported from Aswan, over 800 kilometers away. The workforce, composed of skilled laborers and seasonal workers, exemplifies the organized and hierarchical nature of Egyptian society. 3. Construction techniques. Several theories exist regarding the construction techniques used. The most widely accepted theory suggests that a system of ramps, levers, and manpower was employed to move and position the massive stones. Recent discoveries hint at the use of a straight or circular ramp system. Temples and tombs. 1. Temples. Temples in ancient Egypt were not only places of worship, but also served as economic and administrative centers. The Temple of Karnak, dedicated to the god Ammonius, is one of the largest religious buildings ever constructed. Its hypostyle hall, with 134 massive columns, showcases the Egyptians' mastery of post and lintel construction. 2. Tombs. The tombs of pharaohs and high officials, especially those in the Valley of the Kings, demonstrate advanced engineering techniques. The construction of these tombs involved precise excavation into the rock and careful consideration of structural stability. The tomb of Tutankhamun, discovered in 1922, remains one of the most significant archaeological finds. Hydraulic engineering. Hydraulic engineering was a crucial aspect of ancient Egyptian engineering, essential for managing the Nile's annual floods and ensuring the sustainability of their agriculture. Irrigation systems. 1. Basin irrigation. This system involved creating large basins to capture floodwaters and slowly release them to irrigate crops. The basins were interconnected by a network of canals and dikes, allowing for efficient water management. 2. Shaduf. The shaduf, a simple yet effective device consisting of a lever with a bucket on one end and a counterweight on the other, was used to lift water from the Nile to higher ground. 3. Nilometers. Nilometers were structures used to measure the level of the Nile's floodwaters. These measurements were crucial for predicting the flood's impact on agriculture and planning irrigation. Water management. Water management extended beyond irrigation. The Egyptians also constructed reservoirs and dams to control water flow and store water for dry periods. The Fayum Oasis, for example, was created by diverting water from the Nile into a natural depression, creating a fertile region that significantly contributed to agricultural output. Transportation engineering. Transportation was another area where the Egyptians demonstrated their engineering prowess. The Nile River served as the primary transportation route, and the Egyptians developed various types of boats to navigate its waters. Boats and ships. 1. Papyrus boats. The earliest boats were made from papyrus reeds, a material readily available along the Nile. These lightweight boats were used for fishing and short-distance travel. 2. Wooden ships. As their engineering skills advanced, the Egyptians began constructing larger wooden ships. These vessels were used for transporting goods, including the massive stones used in pyramid construction. The ships were built using planks of acacia or cedar wood, fastened together with mortise and tenon joints and reinforced with ropes. 3. Sailing technology. The development of sailing technology allowed the Egyptians to travel upstream against the Nile's current. The sails were made from linen and were used in conjunction with oars for navigation. Metallurgy and tools. The advancements in metallurgy and tools played a crucial role in enabling the construction of monumental structures and the development of other engineering projects. Copper and bronze. 1. Mining and smelting. The Egyptians were among the earliest civilizations to develop mining and smelting techniques. Copper was mined in the Eastern Desert and the Sinai Peninsula. By the Middle Kingdom, they had also developed bronze, an alloy of copper and tin, which was harder and more durable than pure copper. 2. Tools. Copper and bronze tools, such as chisels, saws, and drills, were essential for cutting and shaping stone and wood. The use of these tools allowed for greater precision in construction and craftsmanship. Iron. Iron became more prevalent in the later periods of ancient Egypt. The techniques for smelting and forging iron were more complex than those for copper and bronze, but the resulting tools and weapons were significantly stronger and more durable. Mathematics and measurement. The Egyptians' understanding of mathematics and measurement was integral to their engineering success. Their mathematical system was based on a decimal system, and they used fractions extensively. Geometry. 1. Surveying. Geometry was crucial for land surveying, especially after the annual Nile floods, which would often wash away property boundaries. The rope stretchers were specialized surveyors who used ropes with evenly spaced knots to measure and mark land. 2. Construction. Geometry was also essential for constructing pyramids, temples, and other structures. The precise alignment and proportion of these structures indicate a sophisticated understanding of geometric principles. Units of measurement. The Egyptians had standardized units of measurement, such as the cubit, approximately 52.3 centimeters, and its subdivisions, which they used for construction and land measurement. The royal cubit, slightly longer than the common cubit, was used for more precise measurements. Legacy and influence. The engineering achievements of ancient Egypt left a lasting legacy, influencing subsequent civilizations and continuing to inspire awe and admiration in modern times. Influence on Greek and Roman engineering. The Greeks and Romans, who admired and studied Egyptian engineering, incorporated many of their techniques and principles into their own practices. Herodotus, the Greek historian, documented his observations of Egyptian engineering, and Roman engineers built upon these foundations to create their own monumental structures. Modern engineering. Modern engineers and architects continue to study and learn from ancient Egyptian techniques. The precision and durability of their constructions serve as benchmarks for modern projects. The study of ancient Egyptian engineering also contributes to fields such as archaeology, history, and even modern construction techniques. Conclusion. Engineering in ancient Egypt was a complex and multifaceted discipline that encompassed various fields, including architecture, hydraulics, transportation, metallurgy, and mathematics. The remarkable achievements of ancient Egyptian engineers continue to be celebrated and studied, highlighting their ingenuity and the enduring legacy of their civilization. Through their monumental structures and advanced techniques, the ancient Egyptians have left an indelible mark on the history of engineering, demonstrating that human creativity and resourcefulness can overcome the most daunting challenges.